All right, welcome everybody to UNSW Canberra at the Australian Defence Force Academy. It's a great pleasure to have you all join us here today. Our apologies for the slight delay in kicking off proceedings, just overcoming the great security features on the local AV systems. My name is Matt Woolley. I am an academic in electrical engineering within the School of Engineering and Information Technology. I will be hosting the information session today. To my right over here we have Associate Professor Michael, more commonly known as Spike Barlow. He's head of school. Over to my left we have Associate Professor Neda Aboutorab. She is the Deputy Head of School for Undergraduate Teaching. Also joining us later in the information session will be 3 trainee officers to my right down here and 1 civilian undergraduate student. So they are going to be Sasha Appelt. That's the civilian student, and we have 3 trainee officers. They are Timothy Bowler, Lauren Kemp, and Angus Lindsay. So welcome to you guys, and thank you for being here, giving up your time on a Saturday morning. With that said, so that introduces everybody. Thank you for being here on this very sunny Canberra morning. It's great to see you all. It's great to see a bumper crowd. If you want to come back for more, there is a See It information booth in the foyer of Adams Auditorium, which will be running throughout the day, 3 to 4 p.m. There will also be repeats of this information session, if once is not enough, where you can kind of continue to grill different TOs and undergraduate students. So with all that being said, let me hand over to our head of school, Michael Spike Barlow, who will be answering the question, why become an engineer? Good question. Thanks, Spike.
Thanks, Matt, and I want to thank you, Matt, for tolerating the lower mic, set for my height rather than yours. I'll repeat Matt's thanks to see so many of you here today and see so many of you enthusiastic about engineering. We've got a fair bit to cover, but a point I want to make is we're trying to paint a picture here, and there are other sources of information on the day down in Adams Auditorium, so go down through the centre of the campus, and we have staff there that you can talk to individually about your particular educational goals that you might have. Yeah, so I'm Spike, as Matt said, and I have the joy of leading our School of Engineering and Information Technology. And we have a mission, which is that we wish to foster the future decision makers, technology decision makers that are focused upon our national security and the defence of this region. So we very much grasp our role and our position here on the campus and as part of the ADFA precinct. Before we go into the full part of the day, I'd like to acknowledge the traditional custodians of the land, the Ngunnawal people, and their leaders, past and present. The way that this presentation is set up is that I will talk for some time about being an engineer, what an engineer is and what you might aspire to. Then Neda will do the heavy lifting for me and for us, talking about the various programs that we have. So we have a number of different engineering degrees that you can do. We also have the Bachelor of Computing and Cybersecurity. We have the BTech Aeronautical as well. So we'll give a broad overview of each of those. And then it'll be back to me to talk about what UNSW is, what the advantage that you might enjoy of being at UNSW Canberra, what being a student here is like as well. So we have a vision, and we also have a saying here in See It, that's our acronym for School of Engineering and IT. See It is its people. So what we produce is chiefly our graduates, the undergraduates that come through, but it's also we have a large number of high degree by research students, so people doing their masters and PhDs, and even our staff. Not all our staff stay. So the output, the products of our school that we are most proud of are our people. And as I said before, our goal is to contribute to the national defence and national security. And we hope and in fact believe that we are the venue of choice for people who hold those values, not just to begin their careers, but to come back time and time again, because education is a lifelong endeavour. It isn't simply you do your undergraduate degree and now I know everything I need to know for my profession. Things are changing in our world, so people come back and they do a coursework master's, or they do master's by research or a PhD. Let's talk about being an engineer. Does anyone want to offer their opinion of what an engineer does for a crust? Just call it out. Build stuff. Yes? Anyone else? Solve problems, mechanical systems. Yes, all those are correct answers. Some of them are partial answers. Engineers solve technology problems. The world's full of problems that we're facing. Engineers build technologies that enable our knowledge economy. And that's very broad. So those of you who are aspiring to be engineers, just close your eyes for a second and imagine what your future is going to be across the next few years into next decade or more. Difficult task to gaze into the future. Defence Force has to do it, universities have to do it, and each of us as individuals have to look into the future as well. There's an image from our grain belt. If you grew up in my generation, the image will look a bit strange. Maybe for the younger members of the audience, it's not so strange. And what am I pointing out? It's a driverless tractor. It's not that there's a tractor harvesting wheat. It's that no driver. That's an engineered solution for safety, for efficiency, and hopefully the farmer whose land is being farmed is off playing with their kids, playing games, or doing something else that's important. So engineering is about making new technologies as well as solving age-old problems that humanity has faced all along. How do we live? How do we have quality of life? So yes, we had an answer from down the front here that engineering is problem solving. It is. Engineers are problem solvers. To study engineering is to build a framework, an approach for lifelong to solve problems. It is a body of knowledge that you acquire as well, but the problems of the future and the technologies of the future aren't even imagined yet. So this problem-solving framework is at least as important as the skills you will learn. Yes, the skills you will learn as you do your degree are going to be applicable when you walk or march out of here if you're a training officer and join your first employment post having a degree. But that problem-solving framework, that's going to last you for your whole life. I'm going to hand over now to Neda to talk about our various programs. Thanks, Neda.
Thank you, Spike. Hi, everyone. My name is Neda. I'm an associate professor in electrical engineering and also the School of Engineering and Information Technology, Deputy of School for Undergraduate Teaching. Welcome to this session, and thank you for joining us today. So today, my role would be to introduce you to the different undergraduate programs that we offer here at the School of Engineering and Information Technology. Spike just told you about your future as an engineer. If you study here, this part of the presentation will look at the things that you'll be studying to prepare you for that future. Okay. This is just a summary slide showing you the different undergraduate programs that we offer here at School of Engineering and Information Technology. So let's start with undergraduate degrees. So basically, undergraduate degrees are the first degrees the degree that a student might take at university. Students might come straight out of school, or they might have worked for a few years, they might have worked in the defense force or elsewhere, and then decided or been selected to come and study their first university degree. As you can see, we have multiple programs across, we offer different engineering and technology programs in our school. We offer Bachelor of Engineering honors in Aeronautical Engineering, in Civil Engineering, in Electrical Engineering, in Mechanical Engineering, and Naval Architecture. We also offer Bachelor of Technology in Aeronautical Engineering and Bachelor of Computing and Cybersecurity degrees. We also teach 2 majors in the Bachelor of Science programs, majors in aviation and computer science. Our engineering programs are 4-year programs. So basically, there are Bachelor of Honors in engineering programs, and our Bachelor of Technology in Aeronautical Engineering and Bachelor of Computing and Cybersecurity programs are 3-year programs. Our programs come in 2 streams. The standard stream, which is the program that most of our students take, and then the talented student program that's called the Chief of Defense Force program, or CDF program. So the CDF version of each program, we also offer. So these programs are by invitation only, but basically students who enter UNSW Canberra with a very high entrance rank and who maintain a high level of performance throughout their program, they will have the opportunity to do several research projects as part of their degree, and basically work one-on-one with academic supervisors in research projects related to their area of study. And basically they can develop problem solving, critical thinking and problem solving, and independent research skills beyond what's available in our standard programs. Also, just have to mention that all of our programs are accredited programs. Our Bachelor of Engineering programs and Bachelor of Technology and Aeronautical Engineering programs are accredited by Engineers Australia, and our Bachelor of Computing and Cybersecurity program is accredited by the Australian Computer Society. So it means that as soon as you graduate, you can start working as a qualified accredited engineer in Australia and many other parts of the world. Also, the same goes with the Bachelor of Computing and Cybersecurity program. And also as part of our engineering programs, our students will spend 60 days gaining practical engineering experience in the workplace to just again prepare them, for entering into the work forces. For Bachelor of Technology in Aeronautical Engineering, this is 40 days. For engineering program, this is 60 days. We also offer different postgraduate programs. So I'm not going to talk into much details about this postgraduate program. The focus of today's session is undergraduate program, but just wanted to show you that our areas of expertise extend to things like capability management, cybersecurity, space engineering, decision analytics, project management, and as also Spike also mentioned, we offer Doctor of Philosophy programs in different engineering programs, also professional doctorate programs in our school. Okay, the first program that I'm going to talk about is the Mechanical Engineering program. So mechanical engineering is about machines. It's about designing, building, manufacturing, maintaining, and improving machines that we use in our everyday lives. These machines can be anything. They can be as simple as a lawnmower or a hedge trimmer, or it can be more complex like a robot, like a space vehicle, or they can be machines that are used in the defense force. For example, they can be a tank or weapon systems. So people who study mechanical engineering can basically end up working in many different areas, in large businesses, small businesses, in the government department, in the Department of Defense, in the services, in consulting companies. There are a whole range of job opportunities available to the mechanical engineering graduates. So let's now talk a little bit about what you would actually study in your program if you study mechanical engineering. So the first year of the program is mainly focused on mathematics, physics, and a little bit of chemistry, and some computer science, like introduction to programming and introduction to cybersecurity, because we believe these are the foundations. These will provide the foundations for future engineering. And then you'll go on to study things like thermofluids, fluid mechanics, mechanics of solids, mechanics of machines, mechanical design, and heat transfer, to just name a few. Because machines can be standing machines or they can be moving machines. And as soon as you have moving parts, you'll have friction and heat transfer. So understanding how these work is going to be important to, in order to be able to design and build machines that can run efficiently. Also, machines can have pipes, they can have hydraulic, they might have lubricants. So understanding how fluids flow is, again, important in being able to design and build the machines that can run effectively. So I mentioned about the jobs. So next I have a video of some of our second year mechanical engineering students preparing for their Warman competition. So Warman competition is a national competition that teams from different Australian universities compete against each other to solve a mythical engineering problem. Our UNSW teams, they have placed first twice in the nationals final, and also they have achieved numerous other podium placements as well. So just a video that some of our students have prepared, I would like to share with you and invite you to watch. So I'll just see if I can get this to work.
Colonists on the planet of Gondwana in the outer fringes of the Milky Way have suffered through years of catastrophes.
Sorry everyone, we'll just start that again.
Drought. Colonists on the planet of Gondwana in the outer fringes of the Milky Way have suffered through years of catastrophes. Drought is now a serious threat, and starvation is imminent unless water is found for their crops. Once again, they're turning to UNSW Canberra student engineers for help. But Gondwana colonists only want the most effective solutions. So they're pitting UNSW Canberra student engineers against each other in a battle of skill. Students will need to solve intricate challenges and show off their talents on a galactic scale before a winner can be chosen. Which team will reign supreme and help restore peace and tranquility back to the planet of Gondwana?
Challenge is to get back to the PowerPoint. Okay, So now I'm excited to highlight our newest undergraduate program at the UNSW Canberra, the Bachelor of Engineering in Naval Architecture program. So this program is, again, very closely related to mechanical engineering program, but will mainly focus on the machines that go in or on the water. So the first 2 years of the program is common with mechanical engineering, so they run in parallel with mechanical engineering. So it also gives opportunity to our students to switch or like transfer to this program in their third year after doing 2 years of mechanical engineering. The same also goes for aeronautical engineering that I'll talk about in a bit. So the first 2 years common with mechanical engineering, and then start to specialize in the third and fourth year of the programs. The specialization starts with looking at things like how a ship floats and remain upright, and then develops towards issues like ship resistance, motion, structure, and then design of the whole propulsion and onboard systems. So this program, again, with the new Government of Australia commitment to shipbuilding, especially the new nuclear-powered submarine, we believe the future for our naval architect graduates would be an exciting one. So in terms of careers, naval architects can go into different roles in Navy and Army. So they can work as a marine engineer and marine engineer submariner in Navy, and Army officer in any of the specialization or corps in Army. Okay, the next program that I would like to talk to you about is our aeronautical engineering program. So again, this is a 4-year program. It's again closely related to the mechanical engineering program. The first year of the program is basically common with mechanical engineering. Again, the focus will be on maths, physics, and some chemistry and some computer science. And then later on you start looking at things like fundamentals of flight, flight's dynamic, aerodynamics, aircraft design, and so I have a list here, applied propulsion, and so on. This is just name a few of our courses in the aeronautical engineering program. So this program, again, in terms of job career options, graduates of aeronautical engineering can work in the space industry, airlines, civilian and military aerospace organizations, and in defense they can work in as an aerospace engineer in Navy, as aeronautical engineer and avionics engineer, Army officers in Army, or as aeronautical engineer and armament engineer in the Air Force. Okay, so the next program is the Bachelor of Technology in Aeronautical Engineering. So this is, again, very closely related to our Bachelor of Engineering in Aeronautical degree, but Bachelor of Engineering is a 4-year degree, but this degree is a 3-year degree. So instead of the honors year, which is a 4th year of the engineering program, I'm going to talk about this honors component at the end of my presentation. But instead of doing a big honors thesis in the 4th year, students in the Bachelor of Technology in Aeronautical Engineering program, they do a smaller project in their 3rd year. I would like to also talk a little bit about the Aviation Major that we offer in the Bachelor of Science program and kind of highlight a few differences. So unlike the Aeronautical Engineering program, both the engineering program, the Bachelor of Technology program, where the focus is on the design, build, manufacturing, and maintenance of flight vehicles, aviation will look at the things that are associated with actually flying those vehicles, those flight vehicles. Things like, what are the human factors that are involved in the flights, how to do air traffic management, or basically how to achieve safety in systems that have both people and machines. So things like that. It's more like looking at the human factors side of things. So In terms of career options, pretty much the same career paths are available to the Bachelor of Technology, Aeronautical Engineering students. The next program that we're going to look we have here is our electrical engineering program. Again, electrical engineering is a 4-year honors program, and we'll look at things like design, build, maintenance, manufacturing, and manufacturing of electronics and telecommunications and computational systems. So the first year of this program is heavily focused on maths and physics and computer science, like computational problem solving, introduction to programming, and then we will start to study things like design of electronic circuits, embedded systems, signals and systems, signal processing, communication system, engineering, electromagnetics, power engineering, and so on, just name a few of courses in this program. In terms of career options, again, electrical engineering have a broad range of career options, both outside defense and in defense for them. So basically, they can work in Navy as electronics engineer, submariner. They can work in Army as avionics engineer, mechatronic and electrical engineering engineer, Army officers, and in Air Force as armament engineer and electronics engineer. Just wanted to mention that in this program we also offer a broad range of elective options. For example, satellite communications, radar techniques and applications, digital image processing, smart grid, and renewable energy are some of the technical elective courses that are available for our students to choose from as their elective options. So now I have another video. This video is one of our electrical engineering graduates, recent electrical engineering graduates, talk about their future career path, and yeah, I invite you to watch this video.
My name's Jane. I have just finished my electrical engineering degree at the University of New South Wales, Canberra, and I'm about to commence a Fulbright scholarship to do a PhD in the USA in August, September of 2022. To me, it means that I had the opportunity to really refine and extend my expertise in electrical engineering. It will give me the skills to develop my interest in signal processing further and hopefully come back to Australia and use that on challenges in the domestic Australian industry.
Just now that we're waiting for the PowerPoint to come back. So Jane was one of our graduate students, electrical engineering student who graduated last year. She was the university medalist, and also she received the Fulbright scholarship. It's a very prestigious scholarship to go and do PhD in the US. I think she's gonna start very soon, her PhD very soon. Okay. So the next program we have here is the civil engineering program. So civil engineering will look at things like, investigating, planning, designing, constructions, managing and maintaining, public utilities that we see around us. In terms of foundation, it's a little bit different from the other engineering that we have, discussed so far, from like a little bit different from electrical engineering or mechanical, aeronautical, and naval architecture engineering. So basically, the first year of the civil engineering, students will focus on maths and some physics and some chemistry, and computational problem solving is one of the computer science courses that they do. And then in the second year, they'll start to look at things like design of concrete, timber, and steel structures, hydrology, environmental engineering, foundation and pavement engineering, transport planning, civil design, and some project management courses, civil project management courses, because civil engineers usually work in large projects, and large projects means large, number of peoples and large period of time. So project management skills, being able to do proper planning, budgeting, and human resource management is becoming very important in this program. So if you study in civil engineering, you also learn all those other things as part of your degree. In terms of career options, civil engineers can work in many different department, institution, organizations, government, defense, non-defense, consulting companies. In terms of careers in defense, they can work in Army and Air Force. So in Army, they can be Army officers in any specialization or corps, and in Air Force, they can be airfield engineers. Okay, the next program I have, oh, don't worry, I'll just probably skip this one. So the next program that we have is Competing as Cybersecurity. It's basically 2 programs. So the Bachelor of Competing as Cybersecurity program is a 3-year program. It's at the pass level, and then there's an optional 4th year, which is another program. It's a Bachelor of Competing as Cybersecurity honors program that the student can complete to receive an honors degree. In this program, the focus in the first year is going to be maths and computational problem solving, introduction to different programming languages, some cybersecurity, introduction to cybersecurity, and then a student will study things like, data structures analysis, networking, computer technology, securing network, digital forensics, and so on. It's just, again, a few of the courses they do in this in their degree. Again, as you probably know, all of the organizations and institutions and companies, they have systems that would have information technology components. So the career options for our graduates from this program is really broad. They can actually basically work in any places in our organization industry. And in defense, the same, is in defense. They can work in Army, Navy, Air Force, because again, all of these services would have IT components that, this student can work on, and therefore this degree can lead into many different options across all the 3 services. Okay, now let's talk a little bit about the honors component of our engineering program. So as you might remember, all of our engineering programs are engineering honors programs. So the last year, the 4th year of the program's called the honors year. So in the honors year, basically students would do some integrated design courses, some technical electives in their area of interest, and also a big capstone research project in their 4th year. We sometimes refer to this capstone research project as honors thesis or honors project or the final year project in our engineering programs. So basically what happens is that the students will work with academics, one-on-one work with academics in their area of specialty, and basically they define a project, they come with some milestones, and basically they're going to work through the project throughout the whole, basically both semesters, semester 1 and semester 2 in their 4th year, and they design, they build, they simulate something like, a lot of times they actually build an artifact in their thesis, and then they present it to their colleagues and a panel of academics as part of their thesis project. So in the School of Engineering and Information Technology, we have a broad range of state-of-the-art facilities and internationally renowned researchers. Our engineering students would have opportunity to work with our academics one-on-one in for their honors thesis. Some of these areas I've just basically captured here. This is not limited to these areas, but areas like hypersonics, infrastructure, impact dynamics, advanced materials, composites, mechanical design, communications, power and electronics, artificial intelligence, complex system security, cyber physical system, sensing, and so on. So you can see, we have a broad range of expertise in our school that our students can do their thesis in any of these areas, or even sub-areas of these areas, or even areas that are not listed here. So this is just basically, this will conclude my presentation. Thank you very much for your attention. I'll just hand over to Spike.
Microphone. Thank you, Neda, for that. Now, I know you've all done really well actually drinking from the fire hose as Neda's poured out so much information for you. I want to point out that if you go down to Adams Auditorium where we have information booth, you can talk to individual academics who will answer your questions. This is being recorded, and we have a recording that we filmed earlier as well, so if you want to go back and hear all that things we were talking about. But this information brochure, which you can pick up down at the booth, contains quite a bit of information about the different programs and degrees, not just ours, but the other schools as well. So there's no test at the end of what we just told you. All right, so hopefully you're considering being an engineer and you want to know why should I come and be an engineer at UNSW Canberra. Let's talk about our organisation. We have had a unique partnership with the ADF for the last 50 years. We also have, so this is a great strength and it contextualises our education. We have cohort of students which is becoming more heterogeneous, more mixed over time. Our large body of students are the trainee officers, so Navy, Air Force, Army, out of school, round 18. We also have what we call advanced students, so someone who's already been in the military is looking at a change of career. They tend to be about in the middle stage of their life and they're coming back to do their first or second degree with us. And we have civilian students. And I really encourage you, if you're interested, to talk to our students here. I need to get out of the way so that you actually talk to the students who have the lived experience of what our degree is. But in civilian students, we have defence-sponsored civilian students called DCUS. I'll talk about that for a little bit. And we have the Commonwealth students. UNSW Canberra is part of the larger University of New South Wales with the main campus up on Kensington. At any time, we have about 65,000 students and a growing alumni body of well over a quarter, approaching 500,000 people who've graduated from UNSW. We are one of the top universities in the world by most of the rating schemes that are used. So we're well inside the top 100 universities. We are research-led, but very proud of our education that we deliver as well. Another great benefit of coming here is the staff-to-student ratios compared to the rest of the country are exceptional. You will know your academic, you'll be able to approach them outside class, you'll know them by name. So my students know me and address me as Spike. This is not so common in Australian universities anymore. Very large classes, layers in between the academics and the students. Here's our campus, and maybe if the balloons are flying today, you might get up and get the same sort of bird's eye view. We're at the right-hand end of that image now in what's called Lecture Theatre North. The trainee officers spend their military time on the left-hand, the southern end of the campus, and the northern end of the campus is the university end of the campus. See it, our school is the largest school on campus. There are 4 schools on campus. We are roughly half of all activity on campus. So a lot of the buildings that are around you as you walk around the campus are ones that hold, see it laboratories, see it workshops, and see it staff members. So at UNSW, we are trying to produce, or we believe we produce, global leaders. Not just people who are experts at military history or electrical engineering, but truly leaders. That's obvious and fairly manifest for military officers, but for our civilian students as well. They will go on to make large, critical decisions that affect their organisation, their community, and the nation in many cases. So we are trying to build not just, this is a point I made earlier, not simply a set of technical skills, but a decision-making and a process and a set of values that are appropriate for senior leaders. I want to spend a little bit of time about speaking about university life, but as I said previously, speak to the students to get a feel for that. Yes, I was a student. It might be hard looking at me to believe that, but I have been an undergraduate as well. But ask about their lived experience rather than speak to us. But let me give some quick high-profile pictures. When you are studying and if you are progressing through your degree in a normal fashion, we have a two-semester process, first half of the year, second half of the year. In each half of the year, you will typically be studying 4 courses. Each course tends to have about 4, 5, 6 hours of contact time per week. That's lectures, labs, tutorials. And then there should be roughly 2, 3, 4 hours of study for that course during the week. So you'll be doing 4 courses. So each day, you're probably spending about 4 or 5 hours in the lab or in a lecture, and then probably you're doing some study that evening as well. There is assessment other than exams and in the classroom, so students need to spend a few hours a week working on their assignments as well. Moving on to the student life, there's an emerging body known as ARC, which has been very active on the main campus, which is now far more active now. Walking down the corridor yesterday, I saw that there was table tennis and badminton tournaments that ARC is organising, and I've been known to play a bit of table tennis myself, so I might participate. One of the things that we want to do and are doing is building a culture beyond the classroom. ADFA, so the defence part of ADFA, has a club system known as VEX, Voluntary Extracurricular Clubs. Sporting clubs, music, various other forms. Some of the clubs are sponsored by or organised by our school, and we have pictures of the different clubs here. So we provide facilities for these clubs. We have an academic coordinator, but the students run these clubs themselves. There's a video, but I'm not going to choose to show it because of time. Down in our information booth in Adams Auditorium, all the videos that we have as part of this presentation are there and are available as well, so you can go and watch them. So there's a great one from the rocket team, some great shots from the camera of the rocket going up, and of course students involved actually talking about that. One of our longest running and particularly successful clubs is the Formula SAE team. They build cars. They're always working on at least 2 cars. There is the car of now and the car of the future, which they are designing. And that car is also taken out, the current car, and is raced. So, and it is any students on campus can participate in this club. It is not just our students, it's not just the mech engineers who are probably the ones most likely to be interested. Any student that's interested in this can participate in this club. One of our activities that we're really proud of is known as YOWE, Young Women in Engineering. Each year we run a 3-day hands-on workshop for young women in years 9 through to 12, where they get to come in and build dams, rebuild lawnmower engines, program robots to play hockey, and a range of other activities, and they're led by some of our best academics. we're about to throw open our recruiting for Yowie, and so please talk to someone if you're interested. It is a great way to sample what engineering is and find out how much fun engineering can be. If you love maths and physics, great, that's easy win. But if you're scared of these things, come and get your hands on and understand that engineering is a practical discipline as well. It's not all theory. It's great to build things. Okay. I'm going to quickly go through the application process, but there are people around campus who will give you detailed information. There are people from our student admin services. There are people from the school who will provide information on this. All right, so I'm going to deal with each of the different cohorts of students separately. So if you want to join ADFA and do a degree, then it's a two-part process and you must engage with both parts. So if you wish to join Army, Air Force or Navy, you must engage with Defence Force recruiting and make a determination of they will make a determination of your suitability. In parallel to that, you must engage with the university admissions process, the UAC, and apply. Now, depending on the career choice that you make with defence, there may be restrictions on what degree that you can do. So if you join Navy, they may direct you into Naval Architecture or Mechanical Engineering. And Air Force as well will often direct students into a narrower range of all choices. In the past, Army has been more, let's say, generous in allowing students to pick the particular degree they want. But given that you know what the particular defence career that you are pursuing is, then you will know which degrees you can apply for, and then you go through the university process. Say you're not choosing to join the three services, but you're interested in coming here. There is the DCUS, the Defence Sponsored Scheme, that will pay for you to attend the university. You must engage with the normal university admission process and with the DCUS application process. There are people on campus who will explain in more detail. So that's one kind of civilian way to join. The second way is I will come as a Commonwealth student. Fundamentally, you engage with the enrolment process in the same manner that you would if you were applying to any other university. ANU, University of Canberra, Monash, any of these, you can engage for the same process here. Not all of our degrees are offered for civilians, and Neda touched on that, and we can explain later if you wish to know which ones are open and which ones aren't. I'm getting near the end of the presentation, and I really hope that if you have questions, you'll ask us and we'll seek to field them. One of the things that, of course, can be quite stressful is, so can I get admitted to the degrees? UNSW is, I was talking about its profile and its achievements, is not a snack just to get into our programs. But we recognise that it's not all about the ATAR, the mark that you achieve in school, that will determine whether you'll be a successful engineer or information technology or cyber expert. So we have various schemes which adjust your score so that we recognise your background and your uniqueness. So there are details here, these adjustment factors that can increase your score by up to 12 points maximum. So different schemes give you various forms of credit. There's schemes based on the sort of leadership traits that you might have shown. That's that EAPL program. Then there's bonus points or these adjustments based on choosing particular courses, which will set you up better or give you a head start for your engineering degree. And then we recognise that people, particularly during these COVID times, have had difficulty in achieving the learning outcomes that they would have done were they not. We were not living through these unusual times, or of course for economic or other crises that people might have suffered in their life. And so that's the educational access scheme as well. For civilian students, there is a further scheme called FIAS, which you apply for. We have been running this, UNSW, for quite some time, and it's yet another way that we adjust and recognise what an individual brings to studying. So I did want to save some time, so I'm about to hand back to Matt as the MC, and what we'll be doing is we'll ask for questions from the audience. We'll repeat them for the people who are online because they can't hear what you're, and then we'll pick the most appropriate members. But I do encourage you again to ask our students for some thoughts as well. Over to you, Matt. Thank you.
Great. Thank you, Spike. Thank you, Neda, and thank you to you all for your attention this morning. So we're now going to pass over to the highlight of today's proceedings. So if I may ask our four present undergraduate students to come forward and step up on stage beside me. Okay, we're all in this together. It's going to be okay. Okay. So up on stage we have Sasha Appelt, who is our civilian second-year Naval Architecture student. We have Lauren Kemp, who's a second-year trainee officer, also studying naval architecture. And we have two second-year aeronautical engineering students, who would be Timothy Bowler and Angus Lindsay. Thank you guys for being here. So the Q&A session, how it's going to work, as Spike's already outlined, we'll throw open the questions. For people online, I'll repeat the questions and then I'll direct them to one of the assembled people on audience. They can bounce them back to me or they can answer them as they desire. So yeah, the floor is yours. Feel free to stick your hand up, ask a question about anything, about the programs, about life here, about... Yes, excellent. Thank you, brave volunteer.
For trainee officer students, what's the balance or mix between academic work and training officer?
Sure, thank you for that question. Let me just repeat it. For trainee officers who are studying here, what is the balance between sort of academic work and military commitments? So if I can throw that across to, maybe we'll start with Angus. Do you mind if I pick on you?
Oh, yes, fine.
So you go to the microphone.
So at ADFA, you're going to do normally 2 hours a morning, most mornings when you'll do joint military education training. So that will either be briefs and lectures from uni staff or defence staff, or you'll be doing PT. And you'll normally have at least one PT session in the afternoon during the week. So you'll have 12 hours a week of military side, which will help you with either your specific service or it'll help you just in general leadership and admin process that you'll need to learn as an officer in defence.
That was very well answered. Thank you, Angus. PT is physical training, by the way, in case you're not aware. Okay, very good. Thank you for starting off. Any more volunteers to throw a question our way? As you can see, we don't bite. Yeah, great. Thank you.
What's your most favourite thing about being a naval architect or studying in?
Okay, so the question for those watching at home, what is the best thing about being a naval architecture student? Naval architecture is in fact our newest program here. It has a lot of overlaps with aeronautical and mechanical engineering, but it's a specialisation which has been brought in given the, I guess, the interest in ship, submarine building and acquisition in defence going forwards. So if I may ask Lauren, is it okay if I ask you? Favourite thing about being a naval architecture student?
Yeah, okay, so I've been in the degree for about 6 weeks so far because I've just transferred across. But even in this 6 weeks, I've had a lot more interaction with my future lecturers than I would with any other degree. So we've already gotten together. I know all the other people in my cohort, the cohorts above, and I can already sort of plan out what I want to do in third and fourth year and what sort of how that will tie into my future job as a marine engineer. I also enjoy systems engineering and sort of the more marine flavoured stuff, as you can see from my uniform. And it's really just this sort of stuff that I enjoy more. So when I look at a ship, think about how it's put together, what goes into it. Yeah, that's sort of why I like naval architecture. It is very similar to marine engineering. It's just more specialised. Mechanical engineering. It's just more specialised. So you can always start off as mechanical engineering, then go into it. But yeah, it's pretty good.
Wonderful. Thank you for that answer, Lauren. Sasha, may I ask you to come forward and discuss? Yeah, thanks.
I think I agree with everything that Lauren said, but also we have the best staff to student ratio on campus. I think in our year it's 8 students so far and 3 academics. So we really do know them, more on a day-to-day basis than in a bigger degree like aeronautical or mechanical engineering. And so it's that engagement that we feel very helped in our journey. And it is more specialized than just a normal mechanical degree. So if you're interested in ships, I do encourage every one of you to apply. We need more people there, I think. That's it.
Yeah, so thank you, Sasha. Great answers from everyone. Good work. Any more questions? Yes.
Do the civilian students stay on campus as well, or is there an opportunity?
I believe the answer to that question is no. I'm not. Yes, civilian students do not stay on campus. It's a good question, though. Thanks. Any more questions out there? Yep, go for it. Okay, so the question is, what are they currently doing in aeronautical engineering? So they're second year students. For context, Timothy, last man up. Excellent.
All right. So in aeronautical engineering, well, for the first 2 years, most degrees are basically the same. So this would apply to everyone in the room, I think, or at least the 3 behind me. So currently we're studying fluid mechanics, fundamentals of flight, engineering math, and mechanics of solids. Yeah, I know what I'm talking about.
You have an exam in only 8 weeks. So
yeah.
Right. So thank you guys. Any more questions out there? So we need prizes for questions. I see a question. Brave young man up there.
If you find a discipline isn't for you, are you able to transfer to another one to begin?
That's a very good question. I might throw that one to Neda, if that's all right.
Thanks, Matt. Thanks for a very good question. The answer in general is yes, but you need to discuss this with both the student admin services and also your service and the ad for recruiting. So basically that might affect your future career path as well. So you basically need to discuss and engage those parties in your decision. Yeah. And some programs have more overlap than the others, so it's probably not that hard to transfer, for example, from mechanical engineering to aeronautical engineering in first or second year of the program. Naval architecture basically also the same, but some might be a little bit further away from the program. For example, civil engineering with aeronautical engineering.
My apologies for those viewing online. I failed to repeat the question. So the question coming in that Neda just answered was, if you enroll in a particular program and you're in defence, can you freely transfer to another program? So the answer is, well, you can transfer to other programs, but defence may constrain you. They have certain needs they want to meet in their workforce ultimately. So it's not as simple a matter as it would be if you're a civilian at kind of here or at any institution. Yes, thank you. So the question is, students here, do they have a far clearer idea of what they want to do from day one? I mean, I think the answer to that question is yes. They essentially, if they're defence personnel, they essentially already have a job, right? So, there is, to be clear, there is a return of service obligation. So Defence funds you for 4 years. Through an engineering program, there is a return of service obligation of 4 years plus 1. So the answer is, I think, yes. Their kind of future is kind of a little bit more guaranteed, let's say. Even at the end of the return of service obligation, these guys are very young, and they will still be very young, however, 7 years from now. It's kind of, I think the answer to your question is yes. from an academic perspective as well, you know, I mean, by virtue of the fact that they're here, they're kind of, you know, they're kind of put into a particular trajectory. Of course, these guys are very young and their interests may change, which is fine. So I mean, there is that return of service obligation, however, if you kind of complete your degree program. I'm not sure if Neda, do you want to add anything in that context?
No, I think you answered the questions. Just might add that, you know, our programs got like a kind of clear structure. So we have fundamental courses, core courses, and then some elective courses. Students can choose from a broad range of elective options depending on their interests or future career path. So for our defense students, they normally know very broadly at the beginning where they're going to be like ending up, and usually in their third year they would know exactly what role they're going to be doing and where. So they have very clear idea of, like, you know, especially like, you know, in terms of when it comes to choosing elective options, they can actually choose depending their, you know, future career path, or they might actually decide to do something a little bit different to get an idea of, like, you know, what other areas might look like. So we don't really prescribe those sort of elective option. Core of the program, everyone has to do the same sort of courses in the core of the program. Our civilian students, they usually, like, you know, come and talk with the lecturers, with the academics, try to get an idea of what it's going to look like, you know, in future, if they do this or do that. We always provide advice and consultation for our civilian students to help them decide what career path they want to continue. Thank you.
Great, thanks Neda. Question?
Allocated spots per program, like Sasha and Lauren spoke a minute ago about Naval Architecture. Is the allocated spots to defence premised on the federal government defence policy and future direction? So you mentioned earlier, the girls mentioned earlier, that it's just arrived at the uni about Naval Architecture, where it hadn't been prior.
Mm-hmm.
So is the spots available to students in ADF based on government policy, not academic policy?
Yeah, so the question coming in is a very good one. So the number of places in each of our programs for trainee officers, are they specified by the government? And I think I might throw this one to Spike to just give you a bit of warning. I may think broadly speaking, the services, Army, Navy, Air Force, they have target quotas. They actually don't necessarily always fill their quotas. I mean, you know, meeting both academic requirements and the requirements of defence, it's kind of a little bit difficult, right? A lot of people can meet one but not the other, and finding the people to meet both can be a little bit challenging. So there's target quotas which come in from defence, but I might throw the rest of that to you, Spike.
Thanks, Matt. Matt's mainly answered that. Each of the services do workforce planning out to about 20 plus years, and they know the sets of skills and the ranks that they need across the years. Then they entrust Defence Force recruiting to recruit for that pipeline which is going through. UNSW and Defence have a contract which governs the relationship between us. That means that we provide a certain number of places and we have set programs that are agreed to. And Naval Architecture is an example of a program that we've now stood up in response to defence need, and we're standing up one at the master's level called Explosive Ordnance, which is again in response to defence's requirements. So we effectively service the pipeline from the three different services, and they are looking right out into the future. As Matt pointed out, there are challenges in actually meeting those recruiting targets, but every organisation is facing these challenges right now.
Terrific. Thank you for that, Spike. So we've got maybe a few minutes left. Are there any more questions out there that you've been kind of thinking about for an hour and is it on the tip of your tongue? Yeah, up there.
Apart from the 12 hours of the officer training, military training, is there any real difference between civilians and ADF students?
So the question is, apart from the kind of additional training that the military officers or trainee officers undergo, is there really any difference in terms of academic programs for the civilians and the trainee officers. So I might attempt an answer to this question, then maybe throw across to Neda for backup. Not all of our programs are open to civilians. So it says in the brochures that you can pick up outside of Adams Auditorium what exactly which programs. But once you're in a program from the academic side, from my perspective as an academic, the civilians and the trainee officers are students first and foremost. And for the trainee officers, being a student takes precedence over their military activities during the time allocated to them for academic studies. So broadly speaking, I would say there's differences of the programs they can undertake, but once they're in a program, I mean, from my perspective as an academic, that they are equal. There is additional oversight on the trainee officers coming from Defence, because from Defence's perspective, they're employees. So there's a little bit more oversight. There's also a little, there's pastoral care to everybody, but there's kind of extra layers coming in with their Defence Association. So Neda, do you have something to add on that one? Neda has nothing to add, so I think I did okay. Excellent, thank you, Neda. All right, so I don't see anyone sort of bursting to put their hand up. I'm going to ask one more question. My question to the TOs is going to be, how did you find adapting to military life coming out of school when you kind of first arrived on campus? I'm going to throw that. You did such a good job the first time, Angus. I'm going to throw it back to you.
So when you first join, you'll end up doing, what we did was 5 weeks of YOFT. It changes year to year depending on need. So basically, it's your 5 weeks of your initial training to kind of get you in the mindset of what defence is like. And then after that, you slide into, you do a few initial courses for maths and English so they can see where you're at. And then they'll put you into your degree, and you'll always have someone in your building that knows or does the same degree or has been where you've been. So you've got other people that are there to help that aren't just uni staff. But other than that, you're going to be doing military stuff in your breaks as well in terms of training, so you get a good balance of uni to military life.
Terrific. Could I actually also ask for your perspective on that, Lauren, if that's okay?
Yes, so as a midshipman, I actually do a year out in the fleet before I come to ADFA. So I do 6 months of officer training, and then I spent 6 months posted to HMAS Choules, and sort of being like a trainee officer on the ship, following the sailors, following the officers, sort of learning how they go. So then when I came to ADFA, it's different from coming from school because you're already commissioned, you've worked in the fleet, and now you have to go back to learning. So it's coming from a different perspective. It's hard in the fact that you have to sort of roll back the military in a different way. But you're already ready to go because you're used to the high-paced environment, you're used to switching on, but now you just have to learn how to study again. Yeah, which is fun.
Yeah, so I think some challenges, but that's okay. A challenge is good every now and again. That we really must wrap up. Thank you so much for your attendance, for your enthusiasm. That's great to see. In terms of acquiring more information about SEIT, don't go yet. There's brochures, so pick up a brochure. So we have a SEIT information booth. That's School of Engineering Information Technology. You can find out lots of information about everything that we've talked about. That will be manned all day from 9 a.m. to 4 p.m. So that's in the foyer outside Adams Auditorium. Also, there are SEIT kind of displays distributed throughout campus. Some of them are downstairs in this particular building. So they're supposed to be kind of fun activities. Check them out, talk to everyone. And above all, ADFA Open Day is a fun day. It's way more fun than any other university's open day, okay? So you've done the hard work now, congratulations, you made it in. Okay, we had to shut the doors 10 minutes to go. But you made it in, you've done the hard work, you've learnt some stuff. Now go out, have fun, enjoy the sun while it lasts, and yeah, have a great day. Thank you.